Hello. Let me today discuss a problem on linear programming problem. That is an optimization problem. See, there is a company which produces products A and B. There is a company that produces two types of products A and B. Profit on A is equal to ₹2 per unit and profit on B is equal to 3 per unit. The two products are being processed on two machineries. On machinery A, machinery H, say G, on machinery G, processing time for A is equal to 1 minute per unit. Processing time for B is equal to 1 minute per unit. 1 minute per unit. Then on machinery H, processing time for A is equal to 2 minutes per unit and processing time for B is equal to 1 minute per unit. Here available time for A for G per day is equal to 6 hours 40 minutes. Available time for G per day is equal to 6 hours 40 minutes. Available time for H per day is equal to 10 hours. Now formulate the LPP. Formulate the LPP. Say this is our problem. So I will read this. The problem is this. There are two products that are being produced by a company A and B. Profit on A is equal to 2 per unit. Profit on B is 3 per unit. On machinery, they are processed on machineries G and H. On G, the processing time for A is equal to 1 minute per unit. Processing time for B is equal to 1 minute per unit. And if it is processed on H, processing time for A is 2 minutes per unit. And here for B it is 1 minute per unit. And the available time on any day is for G it is 6 hours and 40 minutes and for this H it is 10 hours. Now it is for us to formulate the LPP. I'll just tell you. Now I'll put this in a table. I'll put the whole lot of information in a table. Just see how I do this. See, product A and B. It is a machinery G and H, time of processing, time for processing, profit, available time, per day. Here it is It is on G it is 1, for it is H it is 2, it is 1 and it is 2 right here. And here it is 2, 3. Now I have given you the full picture of the problem. Here product A and B, and here G and H are machineries. If it is processed in G, it is 1 minute per unit, and if it is processed in H, it is 2 minutes per unit, and that its profit is 2 per unit. And here it is profit per unit. Likewise B113 and available time. Now we have to formulate the LPP. How it is done? Now you see that it all depends on how many units that you are going to produce in A and B. I do not know what it is, so I will take, let x1 number of units be produced in E. Okay. Now what is the profit? So total profit on a day. Profit on a day is equal to, see, for 1 unit it is 2 rupees. It is producing x1 number of units on any day, so it is equal to rupees 2x1. And let x2 number of units be produced in B, therefore profit. See, for 1 unit it is 3 rupees, for x2 unit it is 3x2. Therefore total profit is, see, I'll write here, now here the total profit is 2x1 plus 3x2. Now this has to be maximized. I'll call this function the objective function Z, and this has to be maximized. So we have to maximize this Z, which depends on the values of x1 and x2. So x1 and z is a function of x1, x2, and x1, x2 are called the decision variables. These are all called x1, x2, x1 and x2 decision variables. They are called the decision variables because they are going to decide the maximum profit. Now you see that this cannot be achieved so easily because it has got certain constraints. The constraints are because of the availability of the machinery. The machinery, they are processed on 2 different machineries, and the machineries are available only for certain time, that is certain number of hours on a particular day. So within that only you can work and earn. But what that wise thing that you must do is you have to decide how many units of the 2 different types of A and B can be produced so that the overall profit is maximum. This is what we are going to do. Now I should formulate now the constraints. How the constraints are formulated, I'll tell you. Now I'll rub off this because of space. I'm rubbing off this. See here, available hours. I'll write here it is 6 hours 40 minutes and it is 10 hours. I'll take this. Okay. Now here you see that, let me come to on G. On G. See, for type A it takes 1 minute. How many units of A we are supposed to produce? x1 units. So the amount of time x2, x1 minutes are, see, 1 and x1 unit, the minutes are taken to process A in G. Correct? So in G I write here, see, in G, on G it takes 1 into x1 minutes minutes are taken to process A in A. Now likewise here for B it is again 1 minute. So 1 into x2 minutes are taken to process. Therefore, what is the total time taken? x1 plus x2. But this x1 plus 2, x2 is the total amount of minutes taken to process in G. But in G, how many minutes are available? 6 hours and 40 minutes. 6 hours and 40 minutes. These are all minutes. x1 minutes and x2 minutes. So it has to be, you have to equate it to only minutes. So how many minutes are there? 6 hours and 40 minutes mean 6 into 60 is 360. 360 plus 40 is 400 minutes. So this x1 plus x2 cannot exceed 400 minutes. It has to be less than or equal to 400 minutes. So this is my constraint 1. Likewise on H, 1 into 2 into x1. Here it takes 2 minutes to process 1 unit. So how much time it takes? 2 into x1 minutes are taken to process on H. I will write it here also in H. Okay. So 2 into x1 minutes are taken to process A on H. I'll write it here. And similarly here 1 into x1, n into x2 minutes are taken to process B in H. B on H. Now you see that what is the total time taken now? So the total time taken equal to 2x1 plus x2. But these minutes, how many minutes are taken? 2x1 plus x2 minutes, but the available minutes on any day is 10 hours. 10 hours means 10 into 60, that is equal to 600 minutes. So this cannot exceed, this can be less or equal to, so this is 600 minutes. Okay. And what are these x1? x1 is the number of units of A produced. Either you produce or you don't produce. You cannot think of a negative production. So a production has to be either equal to 0, nil production, or the production is something is that therefore positive quantity. So you see that x1 can be greater than or equal to 0. It can be equal to 0 or greater than 0. If it is equal to 0, no production. If it is greater than 0, positive production. And likewise x2 is greater than or equal to 0. They are called non-negative constraints. They are called the non-negative constraints. So what is that we are having? Here this tells us that x1 minutes of time is taken for processing A on G, and x2 minutes are taken for processing B on G. So the total time taken is x1 plus x2, which can be less than or equal to 400. Same logic if applied here, you see that 2x1 plus x2 is less than or equal to 600. I give you the explanation for this, that the production can be either positive or equal to 0 in both the cases. Therefore x1 is greater than or equal to 0 and x2 is greater than or equal to 0. Now we have got, so these are the informations. With these informations I am able to arrive at the constraints and also the objective function earlier. Now see, if you put as a whole, now let us put it in a nutshell, whatever things that we have got here. What is that? We have got like this: max of Z is equal to 2x1 plus 3x2. Subject to, what are the constraints? Now you have got here x1 plus x2 is less than or equal to 400. 2x1 plus x2 is less than or equal to 600. x1, x2 greater than or equal to 0. This is your linear programming problem. Now, this is our linear. So, we have arrived at the linear programming problem, namely maximization of z is equal to 2x1 plus 3x2, because z refers to profit. Profit has to be maximized. But this cannot be achieved so easily. It depends on it is subjected to certain constraints. What are the constraints? x1 plus x2 less than or equal to 400 because of the machinery G. And this 2x1 plus x2 is less than or equal to 600. It comes because of the machinery restriction imposed on the machinery H. And that finally x1 and x2 are the productions which can never be a negative quantity. They are called the non-negative constraints and they are greater than or equal to 0. Now this is called the linear programming problem. This can be solved in two different methods. One is the graphical method and another is the simplex method. Graphical method is the one which can be used here because it is a two-dimensional. If it is more than 2 dimensions, it cannot be solved using a graphical method. We have to use only simplex method. And another problem is here. That is, if the number of variables are more than 2, or if the constraints in the sense we have got certain hurdles like this. If the constraints or hurdles are in plenty, in the sense that if they are 5 or 6 or like that, it will be very, very difficult to draw in even the two-dimensional frame. So what we do is we go pause on to the simplex method. So this method can be solved using both, that is graphical method and simplex method. But the simplex method, this graphical method cannot be used if the number of variables are more than 2, that is more than 3 or more, and that if the number of constraints are large. So this is all about the formulation of there are difficult problems on that which will be dealt in the coming days. Thank you.